What's up, team? Hope you all have made progress in whatever project you're working on, and if not, I'll try my best to help get you sorted. In this video, I'm going to go over supporting your horsepower modifications mechanically, and in a future video, I'm going to discuss supporting them electronically. So what does support mean? First, let's talk about what produces or increases horsepower in an internal combustion engine. And if you already have an idea what's going on, I put timestamps in the description if you want to jump ahead. The power created in an internal combustion engine centers around one thing: combustion. For the most part, to significantly increase horsepower in an engine, some changes or improvements have to happen in the combustion chamber. These changes can be influenced by changing or modifying components on the inside or on the outside of the engine block. Increasing your compression ratio via increasing the stroke length is an example of an internal modification, and adding a supercharger will be considered an external modification. In general, if you increase the efficiency of the combustion, you will increase the power output potential, underline potential. If you still feel a little bit rusty on the subject, you can Google 4-stroke combustion cycle, and that should help get you up to speed. The cool thing about supporting mods for power is that it is possible to see gains in power from these supports. So some people may refer to them as components that increase power, and some may consider them support for power. So what I'm going to try to do to keep the debate to a minimum, in this video, supporting mods are modifications that are designed or applied with the goal to increase consistency and reliability. That being said, it is very possible for a part to be considered a power and support mod. So let's tackle that subject first. If you have goals to significantly increase the power of your engine, you should consider how the internals of your engine align with that goal. If your platform was designed to be a low-cost eco-vehicle, like Benji, the engine internals will most likely not hold up well to a 35% increase in output. But on the flip side, if you start with a race-inspired sports car, it may be more resilient to and withstand those changes. In my opinion, once you hit around the 40% mark, you should definitely be considering upgrading your internals if reliability is important for your project. Pistons, connecting rods, the crankshaft, and even the head gaskets can all be considered to be a support or power modification, and that's because all these components directly affect compression. If the component is designed to increase the compression, it's definitely a power mod. But most modern compression increasing components are forged or been through a treatment that makes the part more reliable, and that's what makes those parts more of a power and power support mod. Now, I would consider these components as only support if they do not change the compression. Even without changing the compression, they are still designed to be harder and or tougher than their OEM counterparts. And yes, hardness and toughness have different definitions in material science. So the next question would be, why wouldn't everyone just increase their compression ratio if they're replacing their internals? And the answer is complicated. Like the little answer is because it's complicated. Changing the compression can be complicated depending on the engine design, especially with interference engines. Without getting too far off track, changing the stroke length or piston geometry is a very precise thing, and that means it can be very expensive and or time consuming. In addition, the gains that come from those type of upgrades can usually be made in cheaper and easier ways. But if you have more of an extreme build, those builds usually have increased compression and external power mods like a supercharger or a turbo. So upgrading your engine's internals is a great way to increase the range of your power goals. It serves as a nice cushion for your learning curve, which is why it can be considered a power or support mod. I've seen many projects that start with one power goal, but finish with another. And this is a natural progression because most projects will grow with the driver's experience and or capabilities. You can also upgrade the internals for non-power related gains. Having lighter and tougher rotating assembly usually translates to an engine that can rev faster and can withstand higher RPMs. And this is something that should be considered when building your project. The activity you're involved with and or your driving style may benefit from these changes. So if you plan on increasing your output significantly by adding a turbo, supercharger, or even nitrous, you may want to support that goal by upgrading your engine internals. Now let's talk about supporting engine head upgrades. For heads, there are two main things that are done to create more power: upgrading the camshaft or shafts and porting/polishing. These two modifications essentially do the same thing: increase the max volume of fluid that flows into the combustion chamber. Remember, air is treated as a fluid in fluid dynamics, and we can save the discussion about air velocity and turbulence at another time. To support these power upgrades, you want to have to understand what they can do and how you want your vehicle to perform. Now I would say that that's the first way to support these upgrades, or any upgrades for that matter. But specifically with cams, camshaft profiles can vary greatly and have very specific strengths and weaknesses. Just buying the cams with the most lift and the longest duration may not match other components or your performance preference. Daily driving, circuit racing, drag racing, drifting, etc. have different demands. A max lift cam with a full race disc clutch, single disc clutch, would be miserable in commuter traffic, but it'll be really good for drag racing. The same rules apply for porting and polishing. Larger ports can make power, but if the other components cannot take advantage of that extra volume, it could actually work against you. The next way to support head mods is to upgrade the other moving parts in the head, aka the valve train. Valves, springs, lifters, rockers, push rods, and all the other moving components that you may have can be upgraded for support. The material of these components is usually where the benefits come from. They will be more durable, they're usually lighter, and have more resistance to failure from heat and high RPMs. The valves will definitely experience more heat and pressure as power increases, and the OEM valve design and material may not be able to support the airflow or withstand such a harsh environment. So upgrading the valve train is a great way to reduce the possibility of failure during operation. Now, speaking of harsh environments, you should consider the things that hold everything together: the bolts. Many OEMs use torque-to-yield bolts on head assemblies, which means when properly installed, the bolt is engineered to stretch. This creates a consistent tension over a range of conditions. Significant increases in power may create an environment outside of the range for the OEM parts. In addition, these bolts are often one-time use applications. It is possible to reuse the bolts, but there's a risk of failure. And every time you reuse those kind of bolts, the risk of failure increases. A loose or snap bolt isn't fun in any situation, and when it's your fault, it's that much more salt on the wound. So I suggest upgrading the head bolts/studs while you have it apart the first time. And this applies to all fasteners. You can usually feel or see when a fastener is at the end of its life. Don't put that rusty, stretched out bolt back in. Be patient and source something that has more life left into it. You'll thank yourself in the long run. Alright, so this next section of the video will be about components and modifications on the outside of the engine. There are many things that can be considered support, so I'll go over the fundamentals, and if you have any questions or suggestions, we can chat about it in the comment section. So let's start with fueling. Upgrading your fuel system can certainly be considered a power modification. You cannot make power without fuel. Now, the fuel that you select and how it is delivered is how you support your power goals. My goal with Benji was to make 350 wheel horsepower, and I'm pretty sure somebody somewhere has made this power with all stock components. But with all the upgrades I have, this number can easily be achieved, especially if I were to use E85, meth injection, race fuel, or nitrous oxide. But I wanted a daily that didn't require a special fuel and had a relatively smooth power curve. And I also wanted to challenge myself and the tuner a little, just to see what we can squeeze out of the stock WRX cams and intercooler on pump gas. So to support my goal, I upgraded the injectors, the fuel rails, fuel lines, fuel pump, and I put in an adjustable regulator. This will allow a wider range of volume and pressure that the system can deliver. And as your power goals increase, you will need more fuel available. Higher power goals may require several fuel pumps, a surge tank, additional injectors, and some other components. One component that is important but overlooked often is the fuel filter. You gotta remember, any component that affects fuel flow should be considered when populating your modification/parts list. The next topic up for discussion is cooling. Engine cooling, intake air cooling, trans cooling, fluids, everything. Keeping everything relatively cool should be very high on your priority list if you plan on making significant power gains. Keeping everything in a proper temperature range is a fundamental requirement for a reliable build. Now, radiator and intercooler upgrades are obvious components that address cooling, but there are many other things that you can do to make a big difference in keeping your project cool. The first thing you have to consider is what events you will be participating in. The event will determine your environment. Most automotive cooling systems rely on forward motion to adequately dissipate heat. Aerodynamics and thermodynamics play a huge role in this section. The cool thing about aerodynamics and thermodynamics is that the cost of experimentation and production can be relatively low. You can manipulate scrap materials you have laying around in the garage, or go to a local parts store or hardware store and make an actual effective part. In some cases, one part can lower temperatures and improve aerodynamics, which can increase your power and handling at the same time. So here's a few real-world examples of when stock components or locations may need modification. When a car is drifting, the angle at which the vehicle travels is not forward-facing. Because of that, the amount of airflow that passes through your cooling components is significantly reduced because of that angle. For this application, you want to have fan override switch and or relocate your cooling components so they experience more airflow during and after operation. Remember, always do a cooldown lap. Now, if you have a rally build, the vehicle will most likely experience some pretty nasty conditions. Snow, mud, and dirt will clog cooling fins and sometimes an entire opening. Cooling components mounted low on the front bumper or around the wheel well are subject to become completely ineffective if they're not maintained or located in a poor position. This is why V-mount, top mount, roof mount, and rear mounted components have been used on these vehicles to avoid being clogged by the elements. Having a built-in or handheld sprayer to clean the parts may come in handy between stages. Heat-resistant coatings, wraps, cooling ducts, vents, diffusers, piping, fins, heat sinks, and diversion panels are things that can be added or modified to help keep your project the right temperature, which is a great way to support your power modifications. Testing and building functional components may seem daunting, but you'll be surprised how interesting physics and engineering become when you're applying them to something that you're interested in. So I encourage you to watch, read, and experiment. Now, don't get me wrong, there are definitely some things that you should leave to the experts, but you also want to have a good idea of how things work. And on top of that, experts become experts by learning and experimenting. Gaining the knowledge of how your project works will, at the very least, allow you to purchase the correct components if you do not feel like making them. So back to support. Let's talk structural integrity and safety. Safety is something that, for some reason, a lot of motorsport enthusiasts shrug at. But if you look at the pro level, in most activities, it always comes first. So how does safety fit into supporting power upgrades? It does in several ways. If you plan on increasing your power significantly, you should make sure that the structure of the vehicle can handle it. This may sound like something that should only be considered if you're making a crazy amount of power, but that's not always the case. Engine, transmission, suspension, and chassis components are usually built to be relatively comfortable from the factory, which means they are relatively soft. If you add another 100 horsepower and foot-pounds of torque to their load, they will flex more. And sometimes that flex could be enough to significantly damage components such as wiring harnesses or other hard parts. It really becomes unsafe when it causes weight shifts and throws the car's balance, or something bends and breaks at high speed. In both cases, you can end up hitting the wall, a vehicle, or something that doesn't want to be hit by a car. Bracing and reinforcing certain areas of the vehicle is important when increasing your power. You are building a project you want to drive. Support that goal by making sure you can operate it safely. A wrecked car or ruined life is no fun, and you should definitely get yourself a fire extinguisher because you never know. But on a lighter note, let's talk maintenance. I shouldn't have to say it, but I have to. You have to maintain your vehicle. Even if you don't have any modifications, fluids, spark plugs, air filters, and all the other wear and tear items have to be maintained or replaced after a certain amount of use. You will lose power and reliability if you don't take care of your project. And I know you've spent X amount of money and countless hours in the garage, and you don't want to have to change anything for years. Trust me, in my heart and in my wallet, I agree. But that's not how it works. Ignoring regular maintenance will most likely cost you more time and more money on the back end, and you won't make as much power when your parts are beat. So just take care of what you have. Now, another way to support power-related items are the hoses, tubes, and the clamps that hold them together. A lot of enthusiasts treat these like cosmetic pieces, and honestly, depending on their design and material and application, they just might be. But if you are increasing your power, they should be functional upgrades. When applying these upgrades, consider the material and application. Flimsy hoses with thin walls will most likely collapse under vacuum and burst when pressurized. So get the reinforced products for your intake, boost, and cooling systems. And also, cheap and flimsy hoses will fail when they're exposed to heat or chemicals. So if you want to plan, to upgrade your PCV, vacuum, coolant, fuel hoses, or piping, make sure you have the material that is designed for that application. The clamps used to hold the hoses are just as important as the hoses. As your power increases, the need for stronger and reliable fittings will increase across the board. As you can probably imagine, it's the most obvious when concerning the forced induction components. Save yourself the frustration and embarrassment of being stuck on the side of the road or a DNF on race day by getting quality clamps, and make sure all the tubing is clean when you install it. And just like a completely stock vehicle, you want to check and inspect your maintenance items on a regular basis. You don't necessarily have to do it every week, but while you're doing oil changes or maintaining something else, and especially when you're going to an event, take your time and look over the vehicle. So let's wrap things up with a quick review. You have to consider the activity and environment when you set up your vehicle to make more power. A power mod is designed to make power. A support mod increases reliability, and one part can do both. Fasteners are just as important as large components. Safety and maintenance go a long way, and last but not least, don't be afraid to learn. Projects will come and go, but the knowledge that you can gain from them sticks with you, and in my opinion, they have the most value. So if you appreciate this video, feel free to leave a like or subscribe to my channel. You can also find me on Instagram and Twitter, and there'll be links in the description for that stuff. I hope all your projects meet your goals, and I wish you well in your journey. So stay tuned, and thanks for watching.